process of conserving an artefact from when we find it in the ocean. So we're looking at, perhaps we're off the coast of Cooktown and we're looking for one of the 6 cannons that came off the Endeavour that Captain Cook had to jettison so that his ship didn't get shipwrecked. Now we know they were made of iron, so we use a magnetometer and we do a grid pattern across our ocean floor where we thought the cannons went down until we located our cannon, and here we have here. Now that cannon needs to then be taken back to Sydney for conservation, and the best way to carry that back to Sydney is underwater, and because it's been semi-stable in that environment for hundreds of years, we're going to carry it in the seawater, and that should be totally under the water, we'll pretend it is. Now we're taking our cannon back to Sydney, and the first thing we need to do is, it's going to be covered with a lot of coral because it's been under the ocean for some time. Because we know our artefact is iron, we have 2 choices. We can put it in a water bath with a mild acid like acetic acid or vinegar, or we could mechanically remove the coral with a hammer. Because the iron is a fairly reactive metal, we're not going with the chemical option, we're going to go with the mechanical one and tap off as much of the coral as possible. That tapping off would also remove a bit of the rust too, so we might end up with like the striations because of that. So once we've removed what we can of the coral, we're going to go to our leaching water baths here, and because we know that our artefact is iron, we're going to just spike that water a little bit with some sodium hydroxide because we know that inhibits rusting, so we don't have the poor old cannon getting more rusted in the process of conserving it. Now, it'll sit in the water bath for really weeks, if not months, and we've got a process of diffusion happening. So say we had 100 units of chloride iron on that surface, then that first water bath would leave 50 on the cannon and 50 would go in the water. Diffusion just makes an even amount of the salt in both positions. So we'd have to have successive water baths. So we'd then place our cannon in a second water bath. Remember, we had 50 units of chloride still on it. So in that water bath that's now fresh water, we're going to end up with 25 staying on the artefact and 25 in the water. And we'd successively do that until we knocked all the chloride out. We know chloride cannot stay there because if we leave any there, it's going to lead to further rusting. Now that's going to remove the chloride that isn't chemically bound. We know that some of it is as iron hydroxychloride, and that can only be got out with chemical means that we'll do in our last step. But it will remove all the chloride that is just free. And we know this HSC question is showing, we're told up here that every week we had a new water bath, and we can see that the amount of chloride in the artefact is dropping, but it doesn't go down to 0. We've always got this balancing act happening with the process of diffusion, evening out of the chloride in the artefact and in the water. So we imagine now that we've finished our step of leaching, removing the chloride ion from our artefact, and that brings us up to our most important step that happens all the time when we are restoring a metal object, and that's electrolysis. Our object needs to be connected to the negative terminal, and we need some inert electrode on our positive terminal. We need to also select an electrolyte, and we're going to go with the same one we used for the water baths. We know if we used an acid that would accelerate rusting, so we'd use sodium hydroxide again as our electrolyte. And remembering to connect our artefact, which would be totally under the water, to the negative, we'd carry out electrolysis. Now, chemically, what are we doing? Well, we've connected our artefact to the negative terminal, so we are forcing the rusted iron to reverse the process, to pick its electrons up again and become proper iron, hence conserving our artefact. It's not going to be restored because it's not going to look perfect. We call it conserved. And the anode, oxidation happens at the anode. So at the inert electrode, the electrode itself isn't reacting, but it's enabling the electrolyte, the hydroxide, to oxidise, and we produce water and oxygen. So there will be some bubbling happening at the anode. And that will finish our process of restoring our canon. The canon that's on display at the Maritime Museum, once it was dried, was actually sealed with a coating of wax, and that's a reversible sealant. And if we came up with any other procedure in the future to make it even better, then we could melt the wax off and carry out that procedure. Thank you for watching.